Alright, welcome. Today we are talking about basically our first lesson on circles. So some of this stuff we may be familiar with, some of it will be brand new. But basically we're going to be looking at how to work with the various parts of the circle. Whether that be lines within the circle or the arcs that follow around the outside. So for this first question, we are given the lengths of the diameters of the two circles and asked to solve for a missing piece of the line segments. So we know the diameter is 30 units for circle S, so we notice that since it says S right here, we're talking about the large circle. So our diameter, we know, goes all the way across. The diameter, of the smaller circle is 20 units. So we know that our 20, again, is going to go all the way across the circle. And then they tell us that ds equals 9. So if I notice point D right here, point S right here, that's going to be 9 units. And finally, they ask us to find CD. So I notice, again, point C is here, point D is here, so I am looking for this. We know that the diameter of the larger circle is 30. So if the diameter of the larger circle is 30, that means our radius has to be 15. We know that all three sections of that diameter combine to make 30. So if I take the missing portion, add it to the 9 and the 15, I should get 30. And so now I can solve and find the missing part. And there we go. Alright, so the next thing we want to look at is inscribed and circumscribed polygons. So whenever they say inscribed, they mean that the figure is inside the circle. Whenever they say circumscribed, they mean that the figure is outside. So if I look at the diagram on the right, the quadrilateral is inscribed because it's on the inside, and the circle is circumscribed because it goes around the outside. So in our example, they're describing a picture to us. So we have a square with a side length of 9 that is inscribed in circle J. So the square is going to have to go on the inside. Here's our square. Here's our circle. And if we do it correctly, we want to try to make it so that the circle hits the corners of the square. Like that. We know that each side of the square is 9. And we need to find the circumference of the circle. We know that to find the circumference, right, we either need to know the radius or we need to know the diameter. When I look at my picture, none of the sides of the square go through the middle of the circle, so I do not have the radius and I do not have the diameter. However, if I draw a line going across the square, it's going to hit the middle of the circle. So to find the diameter, I just need to trace out my right triangle. So I know that 9 squared plus 9 squared equals to d squared. So add that up, that is 162 equals to d squared. So if I break down the square root, it's about 9 root 2, which is about 12.7. Question says to find the circumference. So since I have the diameter, just plug it into that second formula. So it's pi times 9 root 2, which I can either write as 9 root 2 pi. I can write it as 9 pi root 2. I'm going to write it that way because that if I put the pi before the square root sign, there's no confusion as to whether or not the square root covers the pi or not. And the reason I'm writing it like this is because it tells me it needs an exact figure. If it wanted you to round or to give an approximate figure, you could put 40.0. Since it says exact, this is the best answer to put. And it was measured in inches. Okay, so the next thing we're going to look at are arcs. So we have basically 3 types of arcs. The arc is talking about the portion of the circle that goes around the outside. So if you have an arc that goes less than halfway, it is a minor arc. If you have an arc that goes more than halfway, it is a major arc. And then if it goes exactly halfway, that's your semicircle. We know that the total number of degrees in a circle is 360. So anything that is exactly halfway is 180 degrees. Anything less than that is a minor arc. And anything more than 180 is going to be your major arc. So how do we use this? Well, if we're looking at this question here, it says to find the measure of arc CD. So you notice the little curve above the C and D. That means we're talking about the arc. You notice the little M in front, just like with angles, that stands for measure. So our answer is going to be given just like it would for an angle, so most likely in degrees. So if I want to find the measure of CD, I find the point for C, trace it around the circle to D, and that's what I'm looking for. And again, it said, find the measure. So I am looking for the number of degrees. So I'm going to put my X in there so that we know we're talking about the angle and not the length of the arc, which we will get to in a moment. So I notice 18% of the circle is taken up by this arc. I know the total number of percentage points is always 100, or in other words, 18% is always going to be 18 out of 100. I don't know what the angle is, but I do know that the total number of degrees for the circle is 360. And so now I have my proportion that I can solve. So 100 times x equals 6,480, which means x equals 64.8 degrees. All right, so the next thing to look at is arc length. Right, so the length is the actual distance, right? It's going to be given in inches or meters or centimeters or whatever they give us for that particular problem, but it is not going to be in degrees because that is a measure, right? So we're going to set it up very similar to how we did the one just before. we know that the length of the arc is going to be proportional to the rest of the circle. So I notice I'm looking for the arc length this time. They gave me an angle in degrees, and I know that the total number of degrees in the circle is always 360. Instead of a percentage, they want me to find a length, right? Well, I know that in order to find the length around the entire circle, I'm going to use circumference. So the length of the arc over the total circumference of the circle is proportional to the measure of the angle out of 360 degrees. So again, we're going to cross multiply. And since it says to round to the nearest hundredth, I'm just going to type my 2 pi times 4 and then multiply that by 75. I can use a calculator. And then divide by 360 to get my answer. So when I type this on my calculator, I'm copying down the answers in full, even though the ones I'm writing on the board are rounded. And I want to do this because I want to keep all of my decimal places wherever possible so that when I round at the very end, my answer is as accurate as it can be. All right, so our last example involves radians. So when you go into your calculator's mode and you press to turn on degrees, you'll notice the word right next to it says radians. Well, a radian is just another unit that measures an angle. Just like you can have feet versus inches versus centimeters all measuring length, we can have two different ways to measure an angle. So a radian is another unit. To convert from radians to degrees, we're going to use the fact that 2 pi radians is equal to 360 degrees. So when we solve our arc length problems, we're going to set them up the same way we would as if they were degrees, only instead of 360, we're going to use 2 pi. Again, I'm looking for the length of the arc. So I know I need to set the length of the arc proportional to the circumference. I know that on the other side I need the angle and then I need the total number of degrees for the circle. However, since this angle does not have a degree sign on it, it means I am not using degrees, right? So if I'm not using degrees, then I'm using radians. So instead of 360, I'm just going to put 2 pi. And then I solve it the same way. So I'm going to cross multiply. Notice that for right now, before I type everything in on my calculator, I'm just going to write it out so I can see everything I need to type. And when I do this, I notice that there's a 2 pi on both sides. Well, if I'm multiplying both sides by 2 pi, then I can basically just divide it out. And so really what I want to type on my calculator is just 5 times the fraction 3 pi over 7. Once again, it says to round to the hundredths place. So I should get about 6.73 centimeters. That's all we have for today. I'll see you guys next time.